How's it going? It's a pretty good Thanksgiving. Yeah. Um, got to relax a bit. It was nice. I saw y'all were pretty busy the last couple of days turning stuff in. I still think it's crazy y'all have so much stuff to do for that class. But I mean, it's not my class. It just seems like an awful lot of work. Yeah. Yeah, this is the last week of classes, and then finals happen, and that's it. Do you have a review for the final yet? I assume you do. Or are you still working on material? Nah, but as long as you turned in the three homework assignments, you're doing fine. Most of your grade for this class will come from your grade for the other class. So I'll have to wait for that to be given to me. That's from whatever your tests are or your exams. And then attendance, of course. Uh, yeah, I need to get that finalized this week, so I don't have as much to do next week, and y'all are already know where you're at going into next week. So that is something I'll work on as the week goes on and make sure that's all up to date. At least we don't have a final for this class. One less for y'all to take, and one less for me to grade. You have a final for the class associated with this one, so we can't get out of that one. But yeah, I'm looking at it right now. Um, Do y'all just want to go through the problems or look at specific ones, or any preference? Which, here's a question, Geneva. There's a bunch of number ones in this review. Like the very first problem on the first part, or a different part? What they've done on the review, if you've looked at it, they've broken up into sections according to content. Start off with functions and graphs, and then goes into financial, or logs and exponents, and then financial mathematics, then matrices, and then statistics, I believe. And there's like some questions on each, starting at number one. So you mean just like the first problem on the first part with domain? Okay. I just wanted to be clear, because I was looking at it and they've not really used a conventional numbering system, I would say. So on, let's see, functions and graphs. Move this down. There we go. It's fine if you do, Zoe. You could try refreshing, see if that does anything, but if it's your connection, it's difficult. It is okay on my end, just so you know. I can usually tell when I'm having problems because it keeps track of what percent of the stream is lost. Alright, so in 1a, we're finding the domain for each of these functions. So for a, f of x is equal to 3x minus 6. This is a polynomial. We know it's a polynomial because it's just terms being added or subtracted with x being raised to non-negative exponents. And in the case of a polynomial, the domain is always all real numbers. For b, f of x equals the fourth root for 2x minus 7. Now, for even roots, this is like square roots, fourth roots, and so on. For even roots, we solve what's under the radical to where it's greater than or equal to 0. So here, we're taking 2x minus 7 greater than or equal to 0. We can add the 7 over and then divide by 2. So our domain is x must be greater than or equal to 3.5. That's only for an even root. An odd root, the domain is all real numbers. So keep that in mind. So it just depends on what root we've been given, how we interpret it. We take 2x minus 7 greater than or equal to 0, or is it just all real numbers in general, if we have like a third root there. Okay, part C. F of x is x squared minus 2x over x minus 1. Now, this is a rational function, and so for these, we determine where the denominator is equal to 0 and leave that number or those numbers out of the domain. So the domain is all real numbers except the values of x that make the denominator 0. So for a rational function, we solve the denominator equal to 0 and leave the solution out of the domain. So here our denominator is x minus 1, so we get x equals 1. And so the domain is all real numbers except x equals 1. Now on D, we actually have another rational function here. The difference is we have x squared plus 1 on the bottom. So we still try to determine when the denominator is equal to 0. But if we end up with x squared equals negative 1, then x, what is the square root of negative 1? Do you all remember that one? does turn out to be I. It is imaginary. Now, I is not a real number. So we would say the domain is all real numbers. Okay. Because the only solution to the denominator equal to 0 was not a real number, and so we haven't excluded anything, so it's all real numbers. Okay, that had one of each type of equation. We have polynomials, rationals, and radicals. Each one has a little bit different approach to finding the domain. Polynomials are easiest because the domain is simply all real numbers. But rationals and radicals each have specific conditions that we're looking for as far as how we determine the domain. Are there other questions? Same section, number 13. Okay, so this is a question about graphs and asymptotes, the rational functions. Now, so we want to find asymptotes in graph. Just as a reminder, for the vertical asymptotes, we solved the denominator equal to 0. And for horizontal asymptotes, there's two scenarios we have to be aware of. So if f of x equals ax to the m on top and bx to the n on bottom, so we look at what's called the leading term on the top and the bottom. This is the term with the highest exponent on top and the term with the highest exponent on bottom. If m is equal to n, then y equals a over b is the horizontal asymptote. And if m is less than n, then y equals 0 is the horizontal asymptote. Okay, so it's really, we start with a comparison of the two exponents on top and bottom, the degree of each function. And if they're equal, then we take the coefficients of those terms and create an asymptote. And if the top is less than the bottom, then y equals 0 is the horizontal asymptote. So for A, f of x is 2x minus 4 over x minus 1. So the vertical asymptote, which I'll just abbreviate v dot a, we take the denominator x minus 1 set equal to 0, so we get x equals 1. And for the horizontal asymptote, the top exponent is x to the first, bottom exponent x to the first. So first equals first, so they're the same exponent top and bottom. So we take their coefficients to create the horizontal asymptote. So it's 2 over 1. So y equals 2 would be our horizontal asymptote there. Now, our instructions are to graph following this. Now, we know the vertical asymptote at 1. We can graph that. That's 1 on the x-axis. Horizontal asymptote at y equals 2. That's 2 on the y-axis. What I usually recommend from here, at least for my students, and I'm not quite sure how you all did this when you went through this, I just have my students make a t-chart. I put the vertical asymptote right in the middle, and then count up 2 values from there. From 1 you go 2 to 3, and then down from there 0 and -1. That way we get 2 points on each side of the horizontal asymptote, and it's easier to graph as a result. We plug each of these 4 other points into this function. For instance, for 3, we'll start with the easier one. 2 times 3 is 6, minus 4 is 2. 3 minus 1 is 2. 2 divided by 2, this is a 1. For x equals 2, 2 times 2 is 4, minus 4 is 0. 2 minus 1 is 1. 0 divided by 1 is 0. For x equals 0, 0 minus 4 over 0 minus 1. So minus 4 over minus 1 is positive 4. And at -1, 2 times -1 is -2. Minus 4 is -6. -1 minus 1 is -2. -6 over -2 is positive 3. And so what we'll do is we'll graph each of these points on this xy plane with our asymptotes already on there. So -1, 3, 0, 4, 2, 0, and 3, 1. And what we'll find happens is the different branches of the graph will fit nicely in between these asymptotes as the graph continues. So it'll end up looking something like that. Okay. For B, h of x is x plus 1 over x squared minus 7x minus 8. think we're going to have to factor the denominator first before we really see what happens here. Because if x plus 1 is a factor on the denominator, something very different happens, which is concerning. Regardless, we at least know that m is 1 and n is 2, so as a result, the horizontal asymptote will be y equals 0. But I want to withhold judgment on the vertical because we need to factor this denominator first. So we think about what multiplies to negative 8, adds up to negative 7, a negative 8 and a positive 1. So x minus 8, x plus 1. Now, that means, now we notice we have x plus 1 on top and on bottom. So effectively, this is, those cancel out, and it's x, 1 over x minus 8. However, that means a vertical asymptote is at x equals 8. And we have a hole in the graph at x equals negative 1. Because that expression canceled out, it does create a hole in the graph at that location. Now, I don't remember us talking about it in our section, but I assume you talked about that in your section, in the other section. Where we have a vertical asymptote versus a hole in the graph. So our vertical asymptote is x equals 8. Okay, so let's graph 7 and 6, and let's include negative 1, because that's going to be an issue. And we'll also look at 9 and 10. That gives us 2 points on each side of the asymptote plus negative 1 where the hole is located. If we plug in x equals negative 1, that's 1 over negative 9. So negative 1/9. At 6, 1 over 6 minus 8, 1 over negative 2 is negative 1/2. At 7, 1 over 7 minus 8, 1 over negative 1 is negative 1. 9, 1 over 9 minus 8, 1 over 1 is 1. And at 10, 1 over 2, 1/2. Okay, so we had 10, comma 1/2, 9, comma 1. So this part of the graph will fit between these two asymptotes. We have 6, comma negative 1/2. 7, comma negative 1, and a hole at negative 1 over here. And so that would be our sketch here. I don't know if you'll actually have one like this with a hole in the graph on the test, but that one's a little more advanced than the rest of these. Okay. So even though that term canceled out, it still caused us some issues that we had to address. Alright, so moving on to part C. F of x equals 1 over x times, actually it's a 4 on top, yeah. 4 over x times x plus 2 squared. Now, on the denominator, the degree, if we were to multiply this out, would be 3. And the numerator has a degree of 0 since it's just a constant. So the horizontal asymptote, since m is less than n, will be y equals 0. And our vertical asymptote, we either get x equals 0 or x equals negative 2. We actually have two vertical asymptotes. Just setting each part of this equal to 0. And because we have two vertical asymptotes, that means we will need a little bit more complicated of a t-chart that we have to create. Oh, crap. Negative 2 is a vertical asymptote. Sorry about that. So negative 4, negative 3, negative 2. There's a vertical asymptote. And then 2, 1, and 0. That's a vertical asymptote. And we need a couple in between negative 2 and 0. I would almost say negative 1.5, negative 1, and negative 1/2. Do all three of those in between just to be sure what happens. It's a lot to plug in, though. That's like 7 different points to plug in. Let me see if I can run through that pretty quick. Negative 4 plus 2 is negative 2. Negative 2 squared is 4 times negative 4 is negative 16. 4 over negative 16 is negative 1/4. Negative 3 plus 2 is negative 1. Squared is positive 1 times negative 3 is negative 3. 4 over negative 3, negative 4/3. Negative 1.5, or negative 3/2, if you will, plus 2 is positive 1/2. Squared is 1/4. 4 divided by 1/4 is 16. 16 divided by 3/2 is 32 over 3. That's awfully large. At negative 1, negative 1 plus 2 is 1. Squared is 1 times negative 1. Negative 1. 4 divided by negative 1 is negative 4. Was this one negative? This one was negative. Yeah. Positive, positive, negative. Yeah. And then at negative 1/2, negative 1/2 plus 2 is 3/2. 3/2 squared is 9/4. 4 divided by 9/4 is 16 over 9. 16 over 9 divided by negative 1/2 means we multiply by negative 2, so negative 32 over 9. That's an unusual graph right there. One, let's see, that's 9, 4 over 9. And 2, that would be 1/4 divided by 2 is 1/8. Okay. Vertical asymptote at 0, right on the axis. Y equals 0, right on the axis. And x equals negative 2. Let's see. So -4. You get -1/4. -3, we get -4/3, which is certainly larger. So this part of the graph will look more or less normal. Okay. The right part, at 1, we get 4/9. And at 2, we get 1/8, so it's decreasing. So this one is more or less normal. Gosh, I gotta plug in like -0.1 just to see what this is, because I'm not sure what happens in between here and here. Just looking at these points, so like -1.5, we get like -10. It's way down here. Okay, then we get to -4, and then -32/9 is -3. So we're getting closer, but you need to know what happens as we get real close to that line. Does it cross over and up, or does it come back down? -0.1 should tell us that. It's going to be negative still. Let's see. 2 minus 0.1 squared times -0.1, and then 4 divided by that answer is -11. So it does come back down as it gets closer over here. That's what I was trying to figure out. So it's a little misshapen, and that's really because of the square. I think is throwing that off. But just hope you don't get this one, because this is a lot of work for this problem. But that's our approach. We can go into some graphing software and figure that out a little more specifically. Let's see, Desmos. F of x equals 4 divided by x times x plus 2 squared. And we can see in this graph more or less what I described. I had a little bit different shape here, but you can see what it's doing. We have our asymptotes at -2 and at 0. This one's going off to the left, this one's on the upper right, and this one's just this little parabolic curve almost going down from there. Okay. I feel pretty good about that. Alright. Other questions? Any other questions on the review for now? Okay. Now remember, we have plenty of time Wednesday, so be sure you look through and see if see if there's any problems where if you just don't know what to do right away, or you try it out and you kind of struggle with where it's going. Just be sure to let me know, and we can go over those. Anything else right now, though, that anyone sees? Mm-hmm. And I assume you'll take some time in the other class going over these as well. I don't know if y'all are done with new material. I don't know if you wrapped it up last Tuesday or not, but hopefully you're just down to review by now. Maybe you have one more day of lecture and then review on Thursday, but and we'll still have Wednesday also. Okay, well, if you all don't have anything else right now, we can stop right there. Um, but be sure you look through and see if there's any others that you would like to work, um, and kind of jot it down for Wednesday's class, and then we can go over that because we'll have plenty of time, as I said. Um, so yeah. We all have a good rest of the day. Mm-hmm. Have a good day. See you Wednesday. Take care. It's always telling to me that as soon as I let y'all go here, I start seeing your work turned in for the other class, so I know y'all are still working. That's good. But unfortunately, you need that extra time. But I don't mind giving it to you. So good on y'all for making good use of your time. But yeah, y'all have a good one. I'll talk to you Wednesday. Bye.